Okay, video number 6 on magnetism and induction. I want to talk about Fleming's right-hand rule and motor action force. Fleming's right-hand rule is just like the left-hand rule, but the right-hand rule is obviously you're using your right hand instead of your left hand. And the right-hand rule is used for motors. So it's Fleming's right-hand rule for motors. So same thing, the thumb is thrust, so we got thumb, thrust. The forefinger is the direction of flux. We can see it's going from north to south, so the forefinger is in that direction. That's pointed in the same direction as that magnetic flux, so forefinger and flux, and then center finger and current flow. You can see that these are same deal. These are on different planes, perpendicular, 90 degrees on a different plane. So nothing much has changed there aside from the fact that we use this for motors, and it's our right hand. So let's take a look at motor action force in action. So I've got, these are my pole pieces. This is considered to be our field, our magnetic field, and they're electromagnets. So in a motor, there's actually an armature, and it spins on this axis. So if we were to just real quickly, an armature is the rotating part, or the rotor is the rotating part, and within that rotor there's the wire is cut into this armature, and it's got a shaft, and that shaft has bearings that sits on a frame, and that actually spins in a magnetic field. And the reason that it spins within that magnetic field is because there's a repulsion between the induced magnetic field in this wire here, and the magnetic flux as it goes from north to south. So what we want to do is take a look at, well, how can I use the right hand rule to determine the direction, whether the direction is going to be in a clockwise direction or if it's going to be in a counterclockwise direction. So we can use a right hand rule for that. But the first thing you need to do is you need to determine, using your left hand rule, what is the polarity of my field pieces over here? What is the polarity here? So these field pieces are in the stator, or the stationary portion of the motor, and the rotor spins on this axis, and that is the rotational portion of the motor. And so if I look at this, I'm going to take my hand and I'm going to place it in the direction, my left hand, I'm going to place it in the direction. So I'm placing my fingers over top of this electromagnet. My fingers are pointing up. And if your fingers are pointing up, your palm's away from you, you wrap it around, you wrap your fingers around that in this direction, your fingers go in that direction, and your thumb is pointing to the north, which would automatically make that the south pole. I'm going to do the same thing over here, so my direction of current is still the same, and I'm going up like that, and I'm going to wrap my fingers around in this direction, and my thumb is pointing to the north pole, and of course that would be the south pole. So that makes sense. I got a north over here, and I got a south over here. So now what we're going to do is, second thing, so we're going to draw our direction of lines of flux. Our direction of line of flux go from north to south outside the magnet, remember. Okay, next thing I want to do is, and it's not absolutely necessary, I can actually determine the rotation using the right hand rule here. So let's do that. Let's take a right hand, and I'm going to take my right hand and I'm going to place my forefinger pointing in the direction that is flowing. The flux is flowing from the north to the south, so in which case I'm going to have my thumb pointing to the right. My thumb's going to be pointing to the right. My forefinger is going to be pointing to the right. Now I look at either one of these. I'm going to look at this one here. So this one is coming towards me. That would be my center finger. So my forefinger is pointing to the right. My center finger, if I'm pointing to the right, my thumb's up. My center finger is pointing away from me. Well, that current, that's the point of the arrow. That current is actually coming towards me. So I'm going to flip my hand so my thumb is upside down. My thumb is now pointing down, but that center finger is pointing towards me now. My center finger is pointing towards me, my thumb is pointing down, and my forefinger is continuing to point in the direction of flux. That hasn't changed. So as a result, with my thumb pointing down, we know that we have a force in this direction that is down. Let's take a look at this one. Same thing. So I'm going to place my finger in the direction the current's flowing. So my finger is going to go in that direction. And if my finger's in that direction and my thumb is pointing up, you can see that my center finger, or you can see that your center finger, is actually pointing into the computer. You're looking at that X as the arrow going away from you. That current is going away from you. So the your thumb is pointing up. So you have a force in this direction here that is going up. So if this one's going down, this one's going up, and it rotates on this here, then the direction must be counterclockwise. You can do it one other way, and that is looking at the characteristics here of what's happening. You can say, okay, well, I'm going to use my left hand rule. I'm going to place my thumb in the direction that it's coming towards me, so the thumb's pointing towards me, and I wrap my fingers around in this direction, in which case there's an induced magnetic field there. So I look at this here, I go, okay, that magnetic field is going that way, and these two are going in the same direction. They're going to repulse each other, and these two are going in the opposite direction, so they're going to attract each other. And if this is the portion that can move and these are attracting each other, then that force is going to want to go that way, and this force is repulsing, that's going to want to go that way. So it's the same thing. It's just simplified by using a right hand rule. So let's take a look at this one here, and I've changed. The only thing I've changed, I've kept all these the same, but the only thing I've changed is that my polarity of my field. So now I can take my field poles and I can change the polarity. So now I've got my current going in the opposite direction. So I'm going from negative to positive, so my current flows in this direction. And now what I'm going to do is with my left hand, I'm going to take that, and it's like I'm grabbing it. I'm going in behind it here like this with my fingers and coming out like this. And my fingers are now sort of, hanging onto it like this. There's my fingers and my fingernails, right? And as a result, my thumb is pointing over here, which is the north, so that would make this the south. And then I look over here and I do the same thing. So I'm going, again, in behind it with my fingers. I'm coming out through the top, and as a result, I have a north there and a south there. So I've got a south and a north here. So the polarity of my pole pieces have changed, and we'll see if that's going to change the direction of the motor. So my current, I'll just mark that in there. Now what I want to do is I want to take my flux and I want to mark my flux direction lines out. So in the direction from north to south. So notice that the direction of the flux field, my field has reversed its direction. So I have the north to south. My flux is going in the opposite direction. Let's take a look. Using our right hand rule, we'll start here. And using our right hand rule, this is I'm going to take my right hand with my forefinger, and I'm going to point it in the direction that flux is flowing. So from north to south. So that's my forefinger, and the current at that point here is coming towards me. That's my center finger. It's coming towards me, in which case I have my thumb is going to be pointing upwards. Your center finger is pointing towards you. Your forefinger is pointing to the left. Center finger is pointing towards you because that is like an arrow. That current is coming towards you. And your thumb is pointing up. So my direction of force in this particular scenario is going to be up. Now we do the same thing over here. Same thing. I'm going to take my forefinger and put it in the direction that the flux is flowing, so in that direction. And then I look at this here. I look at it, so this is going away from me. So my thumb currently is pointing up because my forefinger is pointing to the left. But that current is going away from me. So I'm going to flip my hand upside down. So now my thumb is actually pointing down. My forefinger is pointing away from me, but my center finger is pointing away from me. But my forefinger is still pointing from north to south. So with the right hand rule, I can see that my direction of force there is down. So if I have a direction of force that is up here and a direction of force that is down there, then in this particular scenario I have a clockwise direction. So it proves that if you can change the direction of your field, you can change the direction of a DC motor.